Today we are going to take a look at a prototype of a swarm-like intelligence. I wanted to keep this simple so we can wrap our heads around how swarm systems may work. Let's start with a demonstration. We're going to ask the system, I need a comparison between Fast API and Django, and the system will automatically generate 10 system messages. Sorry, in this case, 5 system messages for 5 agents to come up with answers. And after that, an ultimate answer, final answer will be synthesized. When the answers are given, they're all written here in this JSON file with their respective system messages and their answers. And when the final answer is finished, then we will be writing it to synthesized response.txt. We are done, and the final response is here, which is a synthesized answer from 5 different answers. If you look at some of the system messages, they are varied. As a technical analyst, compare the features and performance. And the next one is a software developer provided detailed comparison between Fast API and Django. As a web development expert, analyze the strengths and weaknesses. As a performance enthusiast, evaluate the speed and scalability and efficiency. So we are able to automatically generate varied and distinct system messages and get useful and distinct answers and synthesize a final answer based on that. This is what we're going to be looking at today. I will be including some example user messages, but here, this is an interesting one. I need an overview of a snake game which features multiple snakes automatically being controlled by an algorithm. And when we do that, we will generate 5 system messages. As a game developer, provide an overview. As an AI enthusiast, as a gamer, as a programmer, as a beginner game programmer, explain the gameplay of a snake that features so, and then the rest of the stuff is being generated now. I have actually gone ahead and got the final answer and gave it to GPT and got this game, which is a snake game, which features multiple snakes being played in the screen automatically. As we see, they are moving around and changing directions and whatnot. There we go. There's only one of them left. And this is being all done automatically, by the way. It's pretty impressive. Let's run it one more time. Here we go. Here's another example. Multiple snakes going off the screen this time. But the final answer to generate this code was generated with the swarm intelligence, or the prototype of a swarm intelligence. We're going to be reviewing the code in 3 stages. First, the swarm sequential functions. Number 1, this actually uses a sequential swarm strategy. Then we will use object-oriented programming and turn our program into a class with parallelism using thread pool executor. And then finally, swarm full auto, which introduces the system message generator and a new synthesized response method. The first 2 code files will be available at Patreon at $9 tier, and the final full auto version will be available at the $30 tier. When you become a patron, not only you will be supporting my programming efforts, but also will have access to the code download for 120 interesting GPT-related project files. Let's begin with the simplest case. Our imports for this is pretty simple. The requirements for this whole project is also very simple. I have a very detailed description in the first file. Once you read this, you should be able to understand everything that is going on, but we're going to be going over the code and talk about it. Here we are setting our OpenAI API key, and we are defining a function called GPT call, which is going to take in a system message and a user message. We will be using GPT 3.5 Turbo, and we are simply assigning the system and the user message here, setting our temperature, max tokens to 20, just for experiment purposes. Feel free to increase this. We will be using streaming responses, and then we are just simply getting our streaming response, printing it, and then returning it. Then we have a function which writes the responses to JSON. Because we will be doing a swarm-like call and we're going to get multiple responses, we are actually mapping or zipping through the system messages and all responses and write them to all responses.json file, such as this. In this first version, we are defining the system messages manually. Here, provide a detailed the first example is actually taken in a user message that says, I need a list of comparison between Fast API and Django. So I have manually written these system messages, such as provide a detailed comparison between the 2 mentioned subjects, list the strengths and weaknesses of each subject mentioned, and analyze the primary differences and similarities between the two subjects. As you can see, I have kept the system messages general and did not mention anything about Fast API and Django. You can actually now change the user message to any type of comparison, and these system messages should work. The reason why we have 3 system messages is that we are going to be looping over these system messages and make a call to GPT for as many system messages as there are, and then get a different behavior because we will be instructing the model to approach the situation differently. So for 3 of our examples, we're going to get 3 different answers. This is what's happening in our functions form GPT call, which takes in the user message, and we have our manually defined system messages. Then we initiate an empty list for all responses, then loop over the system messages one by one and make a GPT call with our user message, which is defined right here, and the system message within this loop. And then we append the response to all responses, and then we write the responses to a JSON using the function we've defined up here once we are out of the loop. And then we get a best response by using the synthesized response function, but this one actually is just choosing the longest response. You might actually apply your own logic here. In the third file, we'll see that we have applied a general synthesis approach here, but this is very simple. So it just returns the longest response. Then we have a main loop, essentially just takes in a user input and then calls the swarm GPT call function, gets the best response, prints it, and then we just run that main loop. Let's run this to see what's happening. So when we run it, now we are getting answers sequentially. Since we've set the token limit to 20, we are quickly done. When we look here, this is our system message, and this is the response from that system message, so on and so forth. And in this first example, we are not saving the final answer, the best response to a file. We are simply just printing it, and it's just the longest response anyway. Now let's move on to the second file, the swarm parallel OOP2, which introduces object-oriented programming and parallelism. But before we continue, I want to mention that at EcoHive AI Academy at www.ecohive.live, you can find and search all my videos along with their descriptions and code download links. I have over 170 projects over here. So in this file, we are additionally importing the thread pool executor from concurrent futures to implement parallelism. We are again importing we are assigning our API key. We are defining a class called GPT Assistant, and in its initialization method, we are initializing the user message and the system messages again manually. Then we have a method called GPT call, which does exactly the same things. Everything else is the same except generate response method, which utilizes the thread pool executor and maps all the system messages to GPT call, which is a method itself, which only takes the system message. This way, we are able to generate all the responses in parallel. So when we run this, we will just see that our responses are generated much more quickly. Just like this. We can increase the mix tokens to, let's say, 200, and then run it again, and you'll be able to see that they're all being generated really fast. And we get the final answer, and the other responses are written to our JSON file as well. Now let's take a look at the full swarm auto, which is the most developed version of this iteration. I just want to say that this is not entirely exactly swarm intelligence. More like it's like a swarm intelligence prototype or an ensemble intelligence. If you hang on till the end, I'll actually explain the differences between this code and a true swarm intelligence. I will be building upon this code. This was my first attempt, first go at swarm intelligence, to wrap my head around it and to be able to explain it to myself, what type of methods and functionality is needed, and to be able to explain to you the same as well. In the beginning, we are also importing term color to be able to print colorfully into the terminal. Here are some of our global variables. How many system messages? This is how many system messages we want to generate. This will determine the number of the swarm, essentially. The system message generation plus the synthesis is part of the swarm as well. So then we would have 7 GPT calls working for this task. In this case, 5 for the response generation, 1 for system message generation, and 1 for final synthesis. Response tokens length, we're setting it to 1000. Each one of these 5 of those responses will take up to this many tokens, hopefully. Model for system message generation, we set to GPT-4. Model for answer generation, which will generate those 5 answers to 3.5 turbo. And for synthesizing, GPT-4. We are setting the API key, and then we are defining a GPT swarm class, which takes in a user message and end system messages, which is defined right here. And we are assigning them right here. Then we have a GPT function call method, which takes in a user message and a model. This is the system message generator. This will be making a function call. Its system message is that it explains to GPT that it's going to need to generate a system message. So this is what we're asking for. A system message is used to guide a large language model to solve a user's query. Provide a list of this many system messages, right? Remember, we are defining this right up here, 5 in this case. So provide a list of 5 many distinct and unique system messages to guide a large language model to solve the user's problem from different perspectives. System message addresses the LLM as you and gives it a role, direction, and scope. Each system message should be unique and provide a different perspective on the user's problem. Give the LLM a distinct role by referring to it as you with a unique perspective each time. So, and then we assign the user message, which is our query. We are doing a streaming function call. Then we have a function definition, which says generate system messages. Description is generates varied and distinct system messages to guide a large language model. Then our parameters are a system messages, which is of type array, and its items are type of string. Description is that distinct and unique system messages. We do require the system messages parameter, and we are forcing GPT to call this function every time. Then we are doing our streaming call, and then return the system messages with JSON.loads, and we return that. And then we have generate system messages, which just calls that previous method with the user message and the model. Next up is the GPT call method, which takes in a system message and a model for answer generation, which we've defined up there. We are setting a word limit using our response token length, which we have defined up here, right? Since we have defined 1000 token length, we are going to input a word limit into the user message. But to do that, I am actually doing a simple math. I am actually taking away 1/3 of our response tokens. In this case, our word limit will be 667, something like that, because that many words will correspond to approximately 1000 tokens, because I am setting the max tokens to 1000 here. And I want to also let the model know some kind of a max word limit so that we try to minimize the cases where our responses will be cut off due to mixed tokens, essentially. So this call just takes in a system message, which will be generated automatically with this function call. And then we ask GPT to please answer using no more than this many words. And here is the user message. Okay. And then we get some streaming responses. Then we write those responses to a JSON, just like we have done. Now we have the synthesized response, which is another GPT call. This is our final call. And this takes in the model for synthesizing final response. The prompt is, okay, so first we get the responses, which is a parameter in this case, and we join them with a new line separation. And our prompt is, based on the following responses, provide a comprehensive and concise synthesis, and we input the joint responses. And synthesis response is an API call with a system message. You are tasked with synthesizing multiple answers into one comprehensive response. Read each one carefully and synthesize them. We input the prompt, then we return again with streaming responses fashion. Using streaming responses, then we write the final answer to synthesize response, and we return it. Now, the generate response method actually uses the thread pool executor to map the GPT call method to all the system messages. So essentially, we are instantiating that many GPT calls as there are system messages. Then we call the write response to JSON for all responses. Then we get a synthesized response finally, and then return that response. And our main function will take in a user message and then call the GPT swarm with the user message. We are instantiating our swarm as the assistant, and then we use this generate response method to synthesize the response. So when we activate this with this user message, we are calling on the GPT function call to generate however many system messages we have defined here, in this case 5. We return them as a list using a function call. Then using thread pool executor, we instantiate 5 so-called restricted agents with a unique system message for each to provide a separate answer based on the user message and based on the distinct system message that it receives. And then once we receive all those responses, then we run the synthesized responses, which actually takes in all those responses and then returns us a final answer. We can run this again with the user query. I need a travel guide for Paris, for example, so we can see what's happening. So our system messages are consisting of, as a virtual tour guide, you can provide the user with information about the top attractions. As a history enthusiast, you can share historical significance. As a food lover, as an art connoisseur, as a language expert. So as you see now, we're going to get 5 distinct answers based on a tour guide, a historical perspective, based on food, art, and language. So this is pretty impressive. And eventually, we're going to get a final answer based on all those varied responses. You can actually view and use these distinct responses differently, creatively. If you like, you can embed them. You can use them to fine-tune different models, perhaps. I might be looking into that. But the final answer, when it's done printing in the terminal, will be saved into the synthesized response.txt. When it's done, we'll take a look at it. We can also run it with different queries, such as best 3-course meal plan for 10 people for a family party event, right? And you can also say, I need how much stuff to buy too, so you can get GPT to output the exact number of items you need to purchase. As you can see, we are done, and this is our synthesized response. So as we can see here that we have a general description of Paris, then a tour guide style, and then taste of Parisian culture, and then it talks about art and gastronomy for food-related activities, cruise, and language. See, there's some mention of the language, so we have a well synthesized answer here, which is hopefully is a combination of all the best elements from the answers from our swarm. I hope you enjoy this. I found this very interesting, and I'll be building more on this. This is just an intro into swarms, hopefully. Like I said, the first 2 files will be available at the $9 Patreon level, and the swarmfulauto.py file. I mean, all the rest of the files will be available at the $30 Patreon level. Thank you for being a patron and for supporting my work. Also, as a final note, let's not forget to compare the true differences between swarm intelligence and this particular code. As you see, multiple agents. Our code use different system messages to guide the GPT model. Each of these can be viewed as an independent agent attempting to generate a relevant response from a unique perspective. In swarm intelligence involves multiple, often homogeneous agents like ants, birds, bees working collectively towards a goal. Parallelism. We simultaneously query GPT model using different guiding system messages. Each system message runs in parallel, contributing to the final output. Swarm intelligence works as in parallel. For instance, ants searching for food simultaneously. Their collective effort results in efficient food source identification. Task decomposition. While the main task remains the same, generating a response, each system message attempts to tackle the problem from a different angle or perspective. In swarm intelligence, agents often decompose a problem into smaller tasks. For instance, like in bird flocking, while the overall goal might be to migrate, individual birds handle tasks like maintaining formation, avoiding obstacles, or searching for food. Synthesis. After obtaining responses from all system message-guided GPT calls, you synthesize or aggregate these responses to derive a comprehensive output. Swarm intelligence would approach this as agents often synthesize their findings for a collective result. For example, ants deposit pheromones on paths to food sources. So this is kind of listing the similarities. You can see there are differences. Decentralized decision making. So swarm intelligence is supposed to be more decentralized. Our code does. There isn't a single predetermined solution. Each system message guides the model differently, and thus resulting in outputs are varied. In swarm intelligence, there is no central authority dictating every agent's actions. Each agent makes decisions based on local information, leading to a decentralized problem-solving approach. So while these are the similarities, the depth of implementation differs. True swarm intelligence systems tend to have more pronounced agent-agent interactions, stronger emergent behaviors, and often more dynamic feedback systems. Still, the parallels in your approach make it an exciting, novel way to interact with models like GPT. I hope you enjoyed this, and please let me know in the comments what your thoughts are. If you have any suggestions on the direction this project should go, I would welcome them. Thank you, and take care.